Hi, I'm Shung, and I'm very excited to be moderating today's discussion on the future of image sensors. Much of my career has revolved around making image sensors and imaging more ubiquitous. I've led technical and commercial teams at Agilent, Micron Imaging, Fairchild Imaging, Aptina Imaging, and ON Semiconductor. Lately, I've been more application focused. I'm currently co-founder and VP of Engineering at SolidSpace, a construction tech startup that's using 3D and 2D imaging at construction sites to analyze quality and monitor progress. The first image sensor that I worked on at Agilent enjoyed success in early PC-connected cameras, now known as webcams. At that time, Skype was the hot new PC app that was driving demand. However, we, like Photobit, OmniVision, and others, made a conscious shift to focus to a non-existent market, cell phones. This may seem like an obvious shift to make now, but at that time, cell phones were these bricks with keyboards and very tiny screens, with only a little bit of bandwidth for text messages. It's quite unexpected and oddly back to the future to find in this pandemic year that I'm Zoom conferencing with a webcam far more than I'm using my smartphone camera. The future really is unpredictable, and this should be a fun topic. It gives me great pleasure to introduce our panelists. I think up on the top left, we have Dr. Sandor Barna. Maybe you could do a little wave there for us, who is the VP of Hardware at Aurora, the company delivering the benefits of self-driving technology safely, quickly, and broadly. Prior to Aurora, Sandor served as Senior VP of Engineering and CTO at GoPro. Before his recent focus on system-level imaging at GoPro and Aurora, Sandor spent almost 20 years leading large teams developing and commercializing CMOS image sensors at onsemi, Aptina Imaging, Micron Imaging, and Photobit, arguably the startup that pioneered CMOS image sensors. During that span, he played a part in shipping over 1 billion image sensors to mobile, camera, and automotive markets. Next, we have Dr. Ryad Benosman, who is jointly a professor at the University of Pittsburgh Medical Center, Carnegie Mellon University, and Sorbonne Universitas, where he does research at the intersection of robotics, computer vision, and neuroscience. In 2007, he did pioneering work in event-based neuromorphic computer vision and has since become a leading researcher in the field. He also works on brain-machine interfaces with a focus on restoring sight through retinal prosthetics, optogenetics, and visual cortex stimulation. Companies he's co-founded include Prophecy, Pixium Vision, and Brainiac. Next, we have Dr. Boyd Fowler, who is the CTO at OmniVision, which has enjoyed a long history of delivering CMOS image sensors and related technologies. He has over 30 years of experience and expertise in image sensors that include his doctoral studies at Stanford. After graduate school, he founded Pixel Devices, a high-performance CMOS image sensor startup that was later acquired by Agilent. Boyd then joined Fairchild Imaging, where he was the CTO and VP of Technology, and introduced high-performance SCMOS image sensors to the scientific market. He's published and spoken extensively on image sensors, and his innovations span semiconductors, optics, devices, circuits, and sensor architecture. Then we have Dr. Sundar Ramamurthy, who is responsible for applied materials business in wafer-level packaging, specialty semiconductors, and epitaxy markets. In this role, he is responsible for fueling AMAT's growth in some of the fastest growing markets in the semiconductor industry, including image and other sensors, Internet of Things, and other emerging markets. In a career at AMAT that spans over 20 years, Sundar and his teams have commercialized 20 plus new products that solved Moore's law scaling challenges through the introduction of new materials, fab techniques, and interface engineering. We'd also like to thank Applied Materials for sponsoring this panel discussion.